Alright, Chapter 1, Mathematics, David E. Stevenson with an introduction. The 10th chapter to review some of the important mathematic topics for the engineering may encounter in the design and analysis of the physical system. The major topics include algebra, trigonometry, complex number, analytical geometry, linear algebra, vectors, sequence and series, differential, integral calculus, and differential equations with Laplace transforms. Alright, 1-1, straight lines, 1-2, quadratic equations, conic sections, spheres, logarithms, triangle, trigonometry, analytical trigonometry, complex number of the matrix, determine the inverses of the matrix, vectors, sequences, series, derivative, maxima, minima, points of inflection, identifying indefinite integrals, definite integrals, differential equations, Laplace transforms, and a summary. Alright, straight lines assigned to each point P coordinate plane as ordered pair AB called the rectangular coordinate of the point. The x-coordinate A is directed with the distance of the y-x point from y-axis to the point, and the y-coordinate is directed distance from x-axis to the point P as shown in figure 1-1. So you have AA and then P, which is the point AB. The distance between 2 points is the point x1, y1, and the point q, x2, y2 of the coordinate plane given the distance formula. Point P and Q is equal to x1 minus x2 squared plus y1 minus y2 squared square root. Rectangular coordinates of the midpoint over the line segments between P, x1, point P, x1, y1, q, x2, y2 in the coordinate plane are given in the midpoint formula. Midpoint is equal to x1 plus x2 over 2, and y2, y1, the y-coordinate is y1 plus y2 divided by 2. Your slope of the non-vertical line distance of is px1 and qx2, y2, where x is not equal to x2 is m is equal to y2 minus y1 over x2 minus x1. If x1 is equal to x2, the line is vertical, its slope is undefined. There are three important forms of the equation of a straight line. Slope-intercept form, y equals mx plus b, where slope is m is the slope and b is the y-intercept. General form, ax plus by is equal to c, where a, b, and c are real numbers. Point slope form, y minus y1 is equal to m is equal m times distributed to x minus ix1, where m is the slope, x1, y1 is the point of the line. Two distinct lines of the slope m1 and m2 are parallel if only the m1 is equal to m2, and are perpendicular if only m1 is equal to negative 1 over m2. Alright, and this shows the examples, and we'll move on to figure 1-2. Our triangle has vertices of a minus negative 2 to b3 2. Find the perimeter of the triangle. Find the area of the triangle. Begin construction of the triangle as shown in figure 1-2 with the distance formula. Obtain your radicals or simplified radical. Radical 20 is equal to 4 times 5. Radical equals 4. Radical times 5 equals 2. Radical 5. The P is the perimeter of the triangle in some lengths sides. Since AB is equal to AC with the triangle is isosceles, BC is not an equal side. Find the area of the triangle. Recall the geometry. Altitude with a non-equal side with the isosceles triangle bisects the side. Thus, line AM is altitude between altitude of the base BC. M is the midpoint of BC. By the midpoint formula, coordinates M as M is equal to 1 plus 3 over 2, 2. Y is equal to negative 2 plus 2 over 2. You get M is the coordinate plane as X is 2, 0, and the distance formula length of the AM is 2 to the fifth. The area of the triangle ABC is half the product of the base altitude. area is half of the base BC times AM, 10 square units. Alternative method of finding the area of the triangle CN. Line CN is the altitude of base of the AB. Since AB is horizontal line segment, CN is 4. Hence, area was 1/2 AB times line AB times CN, or 1 equals 1/2 times 5 times 4, 10 square units. Example 1, 2. In each case, find the equation of the line satisfied with the given conditions. Alright, we're going to skip some of these questions. Quadratic equations, equation from ax squared plus bx plus c is where a and b or c are real numbers. A is not equal to 0 is called the quadratic equation in standard form. The roots of the equation are given in the quadratic form. X is equal to b, negative b plus or minus the square root of b squared minus 4a squared over 2a. This formula, the quantity is b squared minus 4ac, called discriminants, indicate the nature of the roots of the quadratic equation. Two distinct real roots are b squared minus 4ac squared greater than 0. Two complex congregated roots is b squared minus 4ac greater than less than 0. One real root of multiplicity 2 is multiplicity of 2 if b squared is minus 4a squared is 2. And it shows 1, 3 conic sections and graph of the general quadratic equation of the two unknowns is written as a squared plus bxy minus plus cy plus dx plus ey plus f is equal to 0. Exists does not degenerate the graph. A circle is a equals to c and b is equal to 0. Parabola discriminant is b squared minus 4a squared equal to 0. An ellipse, if the circle C, definition 1, if the discriminant is b squared minus 4a squared less than 0. Hyperbola, discriminant b squared minus 4a squared is greater than 0. A circle is a set of all points P in the plane that are fixed distance radius from a given point center is shown in figure 1-3. You show the radius, the center, and the tangent, and pxy, and the center of the circle is 0, 0. A tangent is to the circle line where the end point not within the circle intersects the circle in only one point. Every tangent in the circle is perpendicular to the radius drawn to the point of tangency. The standard form equation of a circle with the center at the origin of radius is x squared plus y squared is equal to radius squared. Parabola is set at all points P in the plane with an equal distance fixed line directress at fixed point focus on not on the line. In figure 1, point P and Q are equal to point F and P and F. The standard form of the equation of the parabola with its vertex at the origin vertical axis of symmetry is x squared plus py. Parabola opens upward if p is greater than 0, opens downward if p is less than 0. Standard form of equation parabola with the vertex at origin horizontal axis symmetry is the parabola opens right of p0. P is equal greater than 0, opens left, P is left less than 0. And it shows the axis of symmetry, X is equal to 0, or Y is equal to A 4px. It shows F is 0, P 0, 0, vertex PXY, directrix Y, Q is XP. An ellipse is a set of all the points in P in a plane with a sum of the whole distance, two fixed points of foci in constant equal length of the major axis of the ellipse. Figure 1-5 of the PF1 plus PF2 is equal to 2A. Shows focus 0B, center PXY, F1 C minus 0, F2 C is equal 0, focuses and vertexes. The standard form equation of an ellipse when its in center of the origin is x squared over a squared plus y squared over b squared is equal to 1. If a is greater than b, the vertex ellipse lies on the x-axis. If the if B is greater than A, the vertex lies ellipse on the y-axis. For this ellipse, the center distance is given as C is greater than C is equal to the square root of the absolute value of A squared minus B squared. Hyperbolas are set all P points in a plane, the difference of whose distance have the two fixed points, foci, and a constant that is equal to the length of the transverse axis of the hyperbola. Figure 1,6 PF1 minus PF2 is equal to 2A. And this shows your hyperbola in figure 1,6 focus vertex center. Isopotenuse y is equal to b over equal to ax. And then on the bottom y is equal to b negative b ax. Y is equal to b negative b over ax. Standard form of equation hyperbola center at the origin is x squared over a2 x squared over a squared minus y squared over b squared equal to 1. Vertex on the x-axis, y squared over a squared minus x squared over b squared is equal to 1. Vertex or axis of the hyperbola center focus distance is given as c is equal to the square root of a squared plus b squared. The graph of the equation xy is equal to x is constant, is a hyperbola, also a hyperbola. In the center of the origin, its center is at the origin. Its azimuths are the x and y axis. Center of the vertex, the conic section translated to origin. Another point, h and k. In coordinate plane with the standard form equation, conic section is just replacing x with x minus h, and with y with y minus k. Then it goes into some examples. Alright. And then we'll pick up here on 1-4 spheres. Assigned to each point P in space of the ordered triple ABC coordinated with a rectangular coordinate. If the point, the x-coordinate A is the direct distance from the YZ plane to the point P, and the y-coordinate B is the direct distance from the XZ plane to the point P. The z-coordinate in the C is direct distance from the XY plane to the point P, as shown in figure 1A. So we have XY axes, and then each distance was the P from rectangular coordinates would be A, B, C at point in the corner. The distance between 2 points in a rectangular coordinates would be P is equal to x1, y1, z1, and Q is equal to x2, y2, z2. Is given the distance with the distance formula. P and point P and Q are equal to the square root of x squared, x2 minus x1 squared plus y2 y minus y1 squared plus z2 minus z1 squared. A sphere is the surface in space. Each point was given a fixed distance radius from the given fixed point center. Standard formula equation with the sphere. The center is HKM. A radius R is x minus h squared plus y minus k squared plus z minus m squared equal to radius squared. General formula equation of a sphere is x squared plus y squared plus z squared plus ax plus by plus cz plus d is equal to 0, where a, b, c, or d real numbers. And then more examples, and then we'll go on to 1-5 logarithms. Logarithmic function with base b is defined as y is equal to log of the b x if only x is equal to b y for x is greater than 0. Base 10 logarithms written as log x is called the common logarithm. A base e logarithm is written as in x is called natural logarithm. To change one logarithmic base to another, use the change base formula. Logarithm bx is equal to logarithm ax over logarithm ab, and then a is greater than 0, and a is not equal to 1. For logarithmic identities, hold all bases b with b is greater than 0 and b is not equal to 1. Log b1 is equal to 0. 2 log b is equal to 1. B log u underscript is equal to u not u greater than 0. Log b to the u is equal to u. If b is greater than 0 and b is not equal to 1, and then the positive real numbers in y, there are three properties logarithms. Log bxy is equal to log bx plus log by. 2 log bx over y is equal to log b x minus log by. Log bx to the nth is equal to the nth log bx. Then it gives you examples. And then we move on to triangle trigonometry. Interior angles of polygons usually measured in radian degree. The relationship of the radian measured with the degree measures as follows. Pi radian is equal to, radians are equal to 180 degrees. Sum of the interior angles of the n-sided polygon is n is minus 2 is equal to n minus 2 times 180, or n minus 2 is equal times pi. The angle whose measure is less than 90, and the pi is divided by 2 is called an acute angle. An angle whose measure is between 90 and 80 is called an obtuse angle. If an angle is 90, it's called the right angle. Pythagorean theorem states the right triangles as x squared plus y squared is equal to r squared, is shown in figure 1.9. Shows that the hypotenuse r, x, y, and midpoint, one point opposite sides of O, adjacent side to O. Figure 1.9, figure 10 shows quadrants, trigonometric functions. You have quadrant, all positive 1, sin and cosecant, both positive 2. Quadrant 3, tangent plus cotangent positive. Quadrant 4, cosine and secant positive. The inverse trigonometry functions are defined as follows. Sin to the negative 1, k is equal to the negative 1 greater than or equal to k greater than equal to 1 donates the angle between negative 90 and 90 degrees whose sin is k. Cosine to the negative 1 k whose with negative 1 is greater than equal to k greater than equal to 1 denotes the angle between 0 and 180 whose cosine is k. Tangent to the negative 1k denotes the angle between negative 90 and 90 whose tangent is k. The law of sin states if the given triangle ratio length of the side of the sine of the angle opposite side of the same constant value. A over sin A is equal to B over sin B equal to C over sin C. Laws of cosine states that the squares of the length of any side of the triangle whose sum of squares of the other side minus twice products of those two sides and cosines angles between them a squared plus b squared plus c squared minus 2bc cosine A. If AB and either two sides of the triangle 0 is the angle between the two sides, then the area of the triangle is A is equal to AB sin 0 over 2. Examples. Alright, we're on laws of sin. We're on the example 13, 14, 15, 16, 17. Alright, 1.7, analytical trigonometry. Because the list is more frequently used with the trigonometry identity with additional trigonometry identities refer to fundamentals engineering reference handbook. Sin 0 is the cosequent. 0 equals 1, 2 cosecant 0, sequent 0 is equal to 1, tangent 0, cotangent 0, 1, tangent 0 is equal to sin 0 over cosine 0, cotangent 0 is equal to cosine 0 over sin 0, sin squared 0 plus cosine 0, cosine sin squared 0, sine cosine squared 0 is equal to 1, 1 tangent plus 1 plus tangent 2, squared plus 0 is equal to secant 2 equals 0, 8, 1 plus cotangent squared 0 is equal to cosecant 2, 0 cosine A plus or minus B is equal to cosine A cosine B plus or minus sin A times sin B, sin A plus B plus or minus B equals to sin A cosine B plus or minus cosine A sin B. 11 sin 2 0 is equal to 2 sin 0 cosecant 0 cosine 2 0 plus cosecant cosine cosine 2 0 is equal to sin squared 0 equal to 2 cosine squared 0 minus 1 equal to 1 minus 2 sin squared 0. and then it gives the examples, and then as an alternative approach, begin tangent 2, 0 is equal to sin squared over cosine, then simplify. Alright, 1.8, complex numbers. The imaginary unit, I, is defined as imaginary unit is equal to the square root of negative 1, where I squared is equal to negative 1. A complex number z is a rectangular form is written as z is equal to a imaginary unit ai plus b, where a and b are real numbers. I is the imaginary unit shown in complex plane, figure 113. A complex number z is a polar form is given. Complex number z is equal to r e times I to the 0 equal to r cosine 0 I sin 0, where a is equal to r cosine 0, b is equal to r sin 0, and r is equal to the square root of a squared. B squared is tangent 0 is equal to b over a, shown in figure 113. The complex conjugate of z is equal to a plus b. The I is z. As z is equal a over bi, the product of z. Z is a non-negative real. The z is a repeated number as a minus bi, the product of z, and times z, the remainder z, non-negative real number a squared plus b. The morphism theory is you have the raised complex number z, polar form, and integral form. Z is equal z to the k is equal to r to the k, e to the ik 0 equal to rk, or cosine k 0 plus I, the imaginary unit sin k equals 0, z the zre to the I to 0, I imaginary 0 r equals r to cosine z, imaginary sin 0, where z is not equal to 0, and n a positive integer with a z has exactly n distance for the nth roots. W to the first, second, third, or W to the ninth minus 1, which are given with the nth root formula. Figure 113 shows the imaginary and the real. R, A, B, and Z is equal to A plus BI on a rectangular form. And it goes into some examples. Know that WZ1 and 2 vertex equilateral triangle general with an nth root complex number for vertex is a regular n-sided polygon complex plane. Alright, matrices and rectangular array numbers enclosed in pair of brackets. Each number of the matrix is called an element. Consider matrix A with m rows and n columns. M for rows and n for columns. A is equal to A going in the column A1 to 1, A imaginary 1, M1, and then this is the matrix is ordered by m times n. It can denote more compactly writing A plus A to Aij. Stands elements for the I for the row and J for the column. Two matrices A equals I to the two matrices A equals A times the row times the column. B is equal to B times the row times the column. Equal both are ordered, or equal if both are ordered m times n, m times x, m times n, or in A's row times columns equal to B row times columns for all imaginary 1, 2, 3 and m, and J 1, 2, 3 m. The square matrix of the ordered n times n. The elements of the the A11 and A22 and M8 and N are called main diagonal elements. The square matrix ordered by the n with the digit 1 along with the main diagonal zeros elsewhere called an identity of the a matrix ordered n times n. Inverse square matrix A ordered n times n is denoted as A negative 1. Product of square matrix A is inverse is A negative 1 is the identity of the matrix. So A times A to the negative 1 is equal to A to the negative 1 times A equal to the inverse. Transpose matrix A de novo the A T is formed switching rows for the matrix A with its columns. 3 rules used to add, subtract, multiply matrix. Matrix divisions are unified. Matrix divisions is undefined. Matrix addition. A is equal to A times row. A is equal to A times row times column. B is equal to B row times column. Our matrix order M times N. The sum of the A, B is the matrix order M times N, defined by A plus B is equal to A rows and columns, B rows and columns. Scalar multiplication. A is equal to rows times column is a matrix ordered with the N times N with K as a real number. Then scale multiplier XA is the matrix order M times N, defined as XA is equal to XA plus rows times column. Matrix multiplication. If A is equal to A rows times column, the matrix order M times N. B is equal to B times rows times column, matrix ordered M times P. Then the product AB is the matrix of order of M times P, that defined using rows type column procedures. Then that is A times B is equal to C times rows times column, where C rows times column is equal to A rows with the 1, B row 1 to the rows, A squared rows squared, B squared columns, plus blah, A to the rows to the number, and B the number of columns. Alright, and then it goes into the examples. Alright, we're on 110, determinants inverse matrix. A determinant order contains n column squared elements arranged with n rows, n columns, n squared order. The determinant of order is n, contains n squared elements arranged with n rows, columns, and n columns enclosed with 2 vertical bars. The minor element of the A rows and columns in determinant with the minor rows and column represented with the determinant of the remains after deleting with the rows and columns, and the element of the A rows and column appears with the cofactor of the element A rows and column. The determinant is denoted by C rows and column differs from M rows and column. The most in sign is given with its C rows and column is equal to negative 1 to the rows plus the columns power plus the subbase rows and column, M's rows and columns. Value of the nth order determinant shown with the found multiplying each element of rows and column corresponding cofactor, adding the products. The sum is called the expansion of the determinant by specified rows and column. Their expansion for the second order determinant rows and columns is A11 to A11 to A21, A12 to A22 is equal to A11 times A22 minus A12 minus A21. That's the expansion determinant. And the inverse of the n in matrix A can be found by the inverse form. A to the negative 1 is equal to the adjunction A over the absolute A. A joint matrix A is obtained with replacing each element, transposing A tangent with a value with a transposed A transpose matrix with value corresponding cofactor. If A's absolute value is equal to 0, then the matrix A does not have an inverse. System with the n linear equations and the n variables x1, x2 to xn, with each equation written in form A for a1 x1 plus a2 x squared a1 x2 plus a2 x2 to whatever ax plus a and xn is equal to k, may be represented with a matrix equation AX is equal to K, where A is an n matrix containing coefficient variables, X is equal to n times 1 matrix containing variables, K is n times 1 matrix containing constants, right hand side of the equations. Solution of the n to the n linear systems of the equations is given as X is equal to A to the negative first times K, provided that matrix A has an inverse. Then it goes into examples. Alright, 111, the vectors. A vector directed line segment in space with the representative force velocity of the displacement-based vectors denoted the boldface I, J, and K are directed segment of rectangular coordinate systems from origin 0, 0, 0 to points 1, 0, 0, 0, 1, 0, and 0, 0, 1, respectively. Positive vectors point space is denoted as the QP ray is equal to X vector I plus Y vector J plus Z vector K is directed in a line segment from the origin 0, 0, 0, 0 to a point X, Y, Z in space as shown in figure 115. Vector A from point 1 with the x1, y1, z1 to point 2, x2, y2, z2 is given by the point ray point 1 to point 2 is equal to A is equal to the vector AX vector 1, AY vector J, AZ vector K, denoted as AX plus X squared plus X1, AY plus AY equal to Y2 minus Y1, and AZ equal to Z squared Z2 minus Z1. Magnitude of length of A is the AX vector I, AY vector J plus AZ vector K, denoted by absolute value of A to define an A is equal to the square root of AX squared plus AY squared plus AZ squared. Vector total's magnitude is called the unit vector is if A is equal to AX vector I, AY vector K, AZ vector K, then A is divided by A absolute value. A is the unit of the vector direction in A. For vectors A, AX vector I plus AY vector K, AZ vector K, AY vector J plus AZ vector K, BX vector I, BX vector J, BZ vector K, X, scalar real number C, the following operations can be performed. Addition, subtraction, A plus minus B is equal to X plus or minus BX vector I plus AY plus B plus or minus BY times J plus AZ plus or minus BZ vector K. Scalar multiplication, CA is equal to CA X vector I, CA Y vector J, CA Z vector K. Dot product A times B is equal to AX plus BX. AX times BX plus AY plus BY plus AZ plus BZ. Once again, data product A minus B is equal to AX times BX plus AY times BY plus AZ times BZ equal to A absolute value A absolute times absolute value B cosine 0, where 0 is the angle between A and B. Non-zero vectors A and B are perpendicular if and only A times B is equal to 0. Write your cross product. A times B is equal to a 3 inject vector I, J, and K columns. I vector AX, BX, J vector B, Y vector J, AY, BY, K, AZ, BZ equal to A square, the absolute value of A and B multiplied times n sin 0, where n is the unit vector perpendicular to the plane formed by A and B. The right-hand rule with the end points in the way of the right thumb points with the fingers curled with the angle of 0 from A to B. Non-zero vectors A and B are parallel if and only A times B is 0. Magnitude of AB is the area of the parallelogram determined by A and B. And then it gives the examples. And we're moving on to sequence and series. Alright, sequence is an order listed numbers A1, A2, A3, A to the nth. Each number the list of the element of the sequence done with a finite number of elements is called the finite sequence. In sequence that continues forever is called the infinite sequence. Series indicating some elements in the sequence A plus A2 plus A3 plus AN. Each number is a series called the term of the series of the terms of the series identical elements of the corresponding sequence. Arithmetic sequences with every element of the first obtained by adding a fixed number to the d preceding element. The constant d is called the common difference of the sequence. The nth element a to the nth over the arithmetic is given by where a is the first element and d is the common difference of the sequence. Thus, some nth number of the nth element arithmetic series of the n terms is given by, and first of all, the common difference is 8, and the n minus equals 8 and 1 plus the number of elements minus 1 times d. The difference, where a is 1, the first element of d is the common difference sequence of the sum Sn of the arithmetic series of the n terms is given by sum of the arithmetic series is given by the number of elements times a to the 1 times n to a to the n divided by 2 is equal to n divided by 2 is times 2 to the a to the 1 plus n minus 1 times d, where a is the first term and a nth is the last term and the d is the common difference of the series. Geometric sequences in which every element after the first obtained multiplying preceding elements of fixed non-zero number r. The constant r is called the common ratio of the sequence. The nth element a to the nth geometric sequence is given as a to the nth element is equal to a to the first element times r to the nth element minus 1. A1 is the first element, r is the common ratio of the sequence, and the sum of the nth of the geometric series terms is given by sum of the geometric series is equal to a the first element times 1 minus r to the last element over 1 to the ratio, fixed number ratio number 0 equal to a1 minus the ratio over times a to the last number in series divided by first and the common ratio, where a is the first term and an is the last term and the r is the common ratio. Ratio is not equal to 1. Ratio greater absolute value is less than 1. The infinite geometric series then series coverage has a finite sum. The finite sum is a to the first over 1 times the ratio. A to the first element is over 1 minus r, where a is the first element and r is the common ratio. If r's absolute value is greater than or equal to 1, infinite geometric series of the series diverges and has no finite sum. The Taylor series generated by a function f as given with the xa is given the function x is equal to f function a minus f function 1a times x1 plus f function 2a times a divided by 2 infinite x minus a squared plus so many numbers in series f to the number f to the last number function of the last number element a times a divided by n to the imaginary times x to minus a to the nth plus whatever. If fka represents the kth derivative of the x, fxa is for discussion derivative of section 113 when a is equal to 0. The Taylor series is called the Malkarian series. Okay, 113 derivatives. Derivative of y equals fx of the respect to the x is defined limited ratio of the tri x and tri y over tri x. The approach is 0. X triangle x equals results in 0. Physical interpretation derivative instantaneous velocity of moving particle. Geometric interpretation derivative slope of the tangent of the curve. Most common notation of the derivative of the function equal to fx. The function fx respect to dx y fx dy over dx. Derivative of the derivative is called for the second. The derivative of y is equal to fx, denoted by the d squared y to the end, f to the nth, or is equal to d squared y over dx squared. Similar derivative of the second. The derivative is called the third derivative. So on. Derivatives are in any order following rules of the differentiation. C is a constant, y, x is the independent variable, u and v are functions of the x, and n is a rational exponent. Derivative of the constant of the dx times c is equal to 0. The derivative of the independent value dx times x is equal to 1. The derivative of power independent variable dx times x to the nth is called n to the x to the nth minus 1. Derivative of the constant function of the derivative of x dx is equal to c times u, or constant times function u of x, and derivative sum of the difference two function direction. Derivative d is x is equal to functions u plus v of x equal to dx u plus or minus dx plus y. Derivative of product of function derivative of x u times v equals to u times dx times v plus v plus dxu. Derivative quotient of two functions dx over u to the v equals v times dxu minus u times dxu over v to the squared. And derivative power of a function derivative of x over u to the nth times nth number of elements times the function of u function x is n minus to the n minus 1 times d to the functions of the x of u. The following is a list of most frequently derived formulas. For additional derivative formulas, refer to Fundamental Engineering Handbook. Dx e to the u is equal to e to the u times dx to the function of the u. X function of u dx is equal to in of u. I-104, or the inverse of u, is equal to 1 over u times dxu. Dx sin u is equal to cosine u times dxu. Dx cosine u sin negative sin u with dxu. The dx tangent u secant squared times u function of x u times dxu. Dx cotangent u cosecant negative cosecant squared times function of xu times dxu. Dxu secant u times tangent u equals dxu. Dx cosecant u is equal to negative cosecant u cotangent u times d derivative xu. Direction sin negative 1 times u is equal to negative 1 over the square root of 1 to the function of x u squared times dxu. Dx tangent negative 1 function u of equals to 1 over 1 plus u squared times dxu. Derivatives may be used to evaluate limits for the indeterminate forms of z divided by u, or infinite over divided by infinite, implying the L'Hospital rule. Function x is results in 0, gx results in 0, x results in a, or if function x is results in infinity and gx results in infinity and x results in a, then limitations of x to resulting in a is equal to function x fx function gx equal to limitations of x resulting in a function fx 1 over gx. Provided later existence as defining implicitly function of x by an equation form f is equal to f xy pair is equal to 0. Dxy may be found by a method called implicit differentiation equation. Fxy 0 term by term respect to the x regarding y as the function of x, and the solve of the resulting equation. The differentiation of x to the differentiation x y times y. The concept of the derivative function one variable may extend to the concept of the partial derivative function two or more variables. Partial derivative of z is equal to the function xy with the respect to x. Ordinary derivative z when y is held constant is used to denote zx is equal zx, and function xy is and dz over dx, or d function df over dx. Partial derivative of z is equal to f pair f x function x y pair with the respect to y ordinary derivative z when x is held constant, usually noted as zy fx pair xy, and then dz in y or df over dy. Then it goes into the examples. And, alright, 114. Maximum minimum points of inflection. Maximum value function value with a greater than other value fundamental and immediate preceding function figure 116a is maximum. Alright, try to finish this up. Alright, 114, maximum minimum points of reflection. Maximum value function value with a greater than any other value function immediately preceding the following. Figure 116a is the maximum minimum value function of values less than any other value function immediately preceding the following. Figure 116b is the minimum. Point of inflection of the curve is the point of which the curve changes from concave upward to concave downward, vice versa. Figure 116c. Point of inflection. So, two first maximum minimum values, y is equal to function x. First call a critical values function by solving the f function 1, x is equal to 0 for each critical value a. Determines the sign of function 2 is a. Minimum x is equal to a if x1 a is equal to 0 and f a is greater than is less than 0. Minimum x a if f function a function 1 a is equal to 0 and function 2 a is greater than 0. Figure 116 shows a, b, and c. Define points of inflection with graph of y is equal to fx. Define root of the equation f function x0 is 0. xa is the root of the equation fx2. Change the sign, the x increases through a, and xa is the point of inflection. And it goes into some examples, and now we're on 115, indefinite length. It's for indefinite integrals. We have basically 2 minutes to read the rest of it. It's inverse operation differential called integration. Indefinite integral function x is denoted by the function as Sanskrit to fx times dx is defined as Sanskrit fx times dx is equal to fx plus c. C is called the integral constant. Dx times f to the xx is equal to function fx. The integration rules of the constant x with an independent variable u and v of the functions of the x, and n is the rational exponent. Integral constant is k, constant of, times d. D's the differential x and plus x k to the x plus c. Integral power independent variable x to the n times d to the x plus x to the nth number minus plus 1 over n plus 1 and plus c is equal to if n is not equal to 1. Integral constant time of the function ku dx plus equals x k of the u dx. Integral sum of the difference two functions. Function of the x function u plus v and plus or minus function v equal times dx is equal to u dx plus or minus v dx. The following integral formulas and inversion differential rules derived form section 113 formula called integration of parts by parts inversion formula differential product. Additional integral forms refer to fundamental engineering reference. UDMD function of x u plus from u to the n1 over n to the 1 plus c to the n equal if n is not equal to negative 1. U dv is equal to uv times derivative integral v du integral eu du is equal to eu plus c. Integral 1 u 1 divided by the function u of x d times du times 1 to the nth the absolute value of u plus c. Constant u du plus sin u plus c. Sin u du plus negative cosine equals negative cosine u plus c. Secant 2 squared constant u of x of the du and equal to tangent u plus c cosecant 2 u du equals the negative cotangent u plus c secant u plus tangent u du is not equals secant u plus c cosecant u cotangent u du cosecant u plus c. Integral 1 square over the square root of 1 to the u 1 minus u to the second is du equals the sin negative 1 u plus c. The integral 1 equals 1 over 1 plus u squared d times uu is equal to tangent negative 1 u plus c. And then that takes care of indefinite integrals. Now we're moving on to Alright, now we're moving on to 116 definite integrals. Definite integrals function x from a b denoted by the symbol of definite integral b and a over with the function fx dx is defined as definite integral fx, and dx is defined as limitations of base to the result of 0 is equal to the logarithm n the base k1 f function e k ax, where e are points on interval a b. The function f is called the integrand a b. Use the lower limit as upper limit, and respectively physical interpretation is a finite integral work done by variable force. Geometrical interpretation definite integral areas under the curve. The fundamental theorem integral calculus calculates two concepts as an indefinite integral, definite integral. Alright, so the definite integral function x and the derivative x is equal to the function x of b and a of the indefinite integral ba of the equal to function b minus function a, in particular integral at where f is integral of fx. Finite integrals are the defined area between two curves of the volume of the solid, revolution, centroid, center of gravity, and area between two curves is found by u of the vertical strip and width of the dx of the horizontal strip of the dy. By using vertical strip a and definite integral length of the dx left hand side right hand boundary vertical strip x is equal to a and x is equal to b. By using vertical horizontal strip, a is equal to the definite integral length of the strip of the dy, where the lower upper boundaries of the horizontal strip are y is equal to c and y is equal to d. Volume of solid revolution is found by using either vertical disk of the thickness dx or horizontal disk of the differential y. Using vertical disk, vertex is equal to the pi times the differential BA, radius of the disk. 2 is dx, where left hand right hand boundaries vertical disk for the x is equal to a and x is equal to b. By using horizontal disk, the vertical disk, the horizontal disk is equal to pi times the definite integral of b a radius of the disk, lower and upper boundaries horizontal disk, y is equal to c, y is equal to d. Coordinates of the centroid of an area a are denoted by the repeating x and y points are given, and the repeated x and y points are equal to my over ma for x coordinate, my over ma for the x coordinate, y mx over a for the y coordinate, where my and mx are first moments for the respective y and axis. Respectively, the first moment is defined as follows. Alright, the m and the my, mx first moment of the respective y and x axis, respectively, the first moment is defined as m moment y is equal to the definite integral ba x length of vertical strip dx for left hand, the right hand boundary vertical strip of the x is equal to a to xb, and first moments of x of the derivative d and e or y, the length of horizontal strip, the differential y, where the lower and upper boundaries of horizontal strip y is equal to c and y is equal to d. and shown in figure 119. And it goes into some examples. And now we're on 117, differential equations. An equation involving the derivative of the differential of one more unknown function of the differential equation in order to order the highest derivative appearing equation with the degrees of the power to which the derivative's highest order is related to the solution of the equation and functional relation between the variables involved with not containing the derivative of the differential satisfied with the differential equation and the differential equation that may be written in the derivative form is dy differential x over the differential y over differential x is equal to the function paired xy over the differential form what is m, and first moment the differential form x plus n functions dy, where m and n are functions of x and y only, are called the differential equation first order and first degree. The first kind of differential equation usually appear with a separable type and a linear type equation. Separable types an equation that can be written in form x for the differential x is equal to y differential y, where x is the function of x's only and y is the function of the y only. The solution is obtained direct integration. Linear type an equation that can be written in form derivative y over derivative x plus point y is equal to q. P and Q's are the function of x only. Solutions are given in linear form. Y e to the p dx equals the integral QE to the p dx times dx plus c. A differential equation is written with the y to the n plus a to the y first plus by to x, coefficients a and b constant, x is 0, or a function x is only, called linear differential equation second order constant. Coefficients, these kind of differential equations appear in homogeneous type, non-homogeneous type equation. Homogeneous type equation in which x is equal to 0, solution x equation depends on character of the roots auxiliary equations m to the second plus am plus b equals 0 is indicated by the table. The one auxiliary equations is formed by replacing k the derivative with m to the k the derivative of k, m to the k the m to the kth power, replacing y with 1. Alright, table 1 shows the root of auxiliary equations, real and distinct roots m and 1 and 2. Y is equal to c1 e to m1 times x plus c2 to e to the m to the 2x, real rooted property of r. Y is equal to c1 e to the yx and c2 yx to the e rx. And then conjugated imaginary roots a plus or minus bi equal to y equals y is equal to e to the a dx times c1 cosine bx plus c2 sin bx. And then there's more. A0 to KXM, A1, KXM1. In your series, you have A0 to KXM1, A1, M to 1, A to the AM series. If A is not the root of auxiliary equation, A to X to the A0, KM plus K1 series. If 0 is the root of auxiliary equation, CA is the AX, A to E is AX, A is not the root of, if A is not the root of the auxiliary equation, AX e to the ax if the root of is the root of the auxiliary equation, ax squared to the ax if the repeated root of the auxiliary equation, c1 sin bx plus c2 cosine bx, c or c2 may be 0. Assume yp equals a sin bx plus b cosine bx if b imaginary number is not a root auxiliary equation, and x a sin bx plus b cosine bx if b imaginary number times imaginary number is the root of the auxiliary equation. Alright, 2 non-homogeneous type equation, an equation which is x is not equal to 0. The solution y is equal to yc plus yp. Yc is called the complementary solution, homogeneous solution. General solution of corresponding homogeneous equations. Y is equal to the particular solution given a non-homogeneous equation. If x is the form of a ex sin bx cosine bx or polynomial in x, then y to the p may be defined with a method of undetermined coefficients. Procedure in this method is to assume that y to the p expression is based on x and its derivative containing certain undetermined coefficients as indicated in table 1-2. To find the values of undetermined coefficients a, b, a to 0, a to 1, a to m, substitute and assume within the form yp differential equations equate coefficients corresponding types. And then we move on, and then we're still in questions. Alright, 118, Laplace transform. The function f, if f is a function defined as t is greater than or equal to 0, use Laplace transform f denoted as the Laplace transforms is into the subsetted order of the function of t is defined by integral Laplace transform function of t is equal to the integral derivative of e to the s to the e times negative st times the function of t times the e to the d to the t equal to the function the fs. Provide integral coverages show that Laplace transforms 8 both basic functions occur quite differently. The entries can be verified or evaluated. The appropriate integral shows f to the t to equal to 1 equals Laplace transformation 1 equal to 1 over s, or s is greater than 0. Function t is equal to a eat. Laplace transformation of e subset e to the at is equal to 1 over sin over s to the negative 1 over s minus as is greater than a. Function t is equal to t to the nth, where Laplace transforms t to the nth equals to the n imaginary number over s to the number to the nth element plus 1, s is equal to 0. Alright, 4, the ft sn kt, sin of kt is equal to k, s squared plus k squared, k over s squared plus k squared is s is greater than 0. For the function t of the cosine of kt, the Laplace transforms cosine k subset kt equal to s is equal over s squared plus c squared, s is greater than 0. Function t is equal to t to the nth, e and times e to the at power, a times t power, Laplace transformation t to the nth times e to the times a to the t power subset equal to n to the negative n to the number n to the negative n times imaginary numbers s to the negative over s to minus a with the n plus 1 power, s is greater than a. Function ft to the at sin kt, Laplace transfer e to the at sin kt equal to k over s minus a squared plus k squared, s is greater than a. Function t equals e to the at cosine kt, Laplace transforms e at cosine kt subset equal to s minus a over s minus a plus k squared equal is if s is greater than a. There are two places Laplace transform property that mimic the property of the integration regarding multiplication, constant, sums, and differency. Laplace transformation subset kf times t is equal to Laplace transform f subset f function t. Laplace transform function t plus or minus function gt, and gt equals Laplace function subset f function t plus or minus Laplace function gt. The function fs represents the Laplace transform function ft, and ft inverse Laplace transforms fs. Function t is equal to Laplace inverse Laplace transforms f as the s. Basic inverse Laplace transforms are found in adjusting constant matching their forms to entries. Table 1.3, more complicated Laplace transforms, partial fraction, decomposition, rational expression obtained the entry figure. Table 1.3, partial fraction, decomposition sections. There are two cases are considered. Case 1, distinct linear functions. Each linear function a as b occurring in the denominator of a rational expression is assigned single partial fraction form a over as plus b. A is the constant to be determined. Case 2, distinct irreducible quadratic factors. To each distinct irreducible quadratic factor, a times s squared plus bs plus c occurring denominator rational expression, assigning single partial function of as plus b over as squared plus bs plus c, where a and b are constant. Determine integration parts of section 115 yields Laplace transform first and second derivatives. Laplace transform subset function 1 ft equals s Laplace transformation ft subset ft minus f0. Laplace transfer of function 2 f2 function minus s2 equals s2 Laplace function f2 minus fs0 minus f10, because these results Laplace transformation in ideally suited with the differential equation for the constant coefficients in which values f1 and f0 are known. Then it goes into examples, and then 119, the summary. The chapter has reviewed essential mathematics skill for the concepts of gravity engineering analyzing design physical systems. It's important to know that the mathematics chapters form a foundation for many of the other chapters' manual. Therefore, essentially feel confident in most of the material before continuing. Make notes of any difficulty you have with the mathematics in other sections of this manual. Refer back to the topic and section review whether necessary. If more review on any of the topic is required, refer to one of many current pre-calculus calculus texts that are available. And it goes into practice problems, and we should be on Chapter 2, Engineering Probability and Statistics.